All right, let's talk about observability. We're going to dive into how modern IT teams actually make sense of their super complex systems. We're going from the total chaos of a system failure to the kind of clarity that lets engineers finally get some sleep.
Okay, so let's just start with a feeling that, well, if you're an engineer, you know this feeling all too well. This quote just nails it, right? That absolute panic of a major outage. It's just a tidal wave of red alerts, everything is screaming at you. And you're thinking, somewhere in this sea of noise is the one tiny thing that actually broke. And this kind of chaos, it's not an accident. It's actually a direct result of how we build software today. Think about it. We've moved way past simple applications. Now we're dealing with these incredibly complex systems built on microservices, containers, and just sprawling cloud infrastructure.
So the whole challenge has fundamentally changed. It's not just about keeping the lights on anymore. I mean, as these systems get more and more distributed, the real challenge is figuring out what's even happening inside them in the first place. Because when one little piece fails, it can honestly look like the entire system is on fire all at once.
So for decades, our main weapon against this chaos has been monitoring, right? It's the classic approach. And really, it's the foundation for managing any system. I like to think of monitoring as kind of like the check engine light in your car. It's awesome at telling you that a problem exists, but it can't tell you if it's just a minor sensor issue or if your engine is literally about to fall out. It tells you that something is wrong, but it gives you absolutely no clue about the what or the why.
And honestly, that's its biggest limitation. With monitoring, you have to know what might break ahead of time just to set up an alert for it. This is really the first level of maturity in managing a system. It's absolutely essential for basic health checks, for sure, but it only gets you so far.
Okay, so what about the problems you can't predict? The weird once-in-a-lifetime failures that you've never ever seen before? Well, that's where observability comes in. And believe me, it is a total game changer.
It's really the difference between just knowing you have a fever and a doctor running a full set of diagnostics to find the underlying infection. See, observability doesn't just show you a bunch of data. It gives you the tools to explore that data, to ask questions you didn't even know you needed to ask. And this right here, this shows the fundamental shift in mindset. It's huge. We're moving away from a reactive posture, just waiting for things to break, and moving to a proactive, exploratory one. A huge difference is the data itself. Monitoring is all about predefined metrics, but observability, it brings in this rich, high cardinality data. That's data with tons of unique detail. And crucially, traces, which let us hunt down those unknown unknowns, the problems you literally could never have predicted. So, how does observability pull off this deeper understanding? Well, it does it by combining three core data types. You've probably heard of them. They're famously known as the three pillars of observability.
First up, we've got metrics. Just think of these as your system's vital signs: CPU usage, response time, error rates, that kind of thing. They give you that quick, at-a-glance view, so when a metric suddenly spikes, you know something's up. That's the starting point for your whole investigation.
Okay, so if metrics tell you what happened, logs are there to tell you why. If we stick with that medical analogy, if metrics are the vital signs, then logs are the super detailed doctor's notes. They're just these time-stamped records of every specific event, and they give you all that rich context you need to understand what's behind that spike. And finally, we have traces. And let me tell you, this is what truly unlocks observability in today's complex systems. A trace is basically like putting a GPS tracker on a single user request. It follows its entire journey from the moment they click all the way through maybe dozens of different microservices, and it shows you precisely where and how something went wrong. This is how you find that needle in the haystack. All right, so this all sounds great in theory, but how do teams actually put it into practice? Well, the market is just filled with incredibly powerful tools, but yeah, they're often complex and they can get really, really expensive fast. Let's just take a quick look at two of the biggest players out there, Datadog and New Relic. Datadog is really known for its deep, granular control over infrastructure monitoring. New Relic, on the other hand, it kind of excels with a more user-friendly, app-focused experience. But they both come with their own set of challenges. Their pricing can be super complex and unpredictable. Plus, because they're cloud-only, some companies get nervous about data privacy. And all of this can lead to that dreaded feeling of vendor lock-in.
And so, because of these challenges, the vendor lock-in, the unpredictable costs, it really sparked this powerful movement for a more open, a more flexible way to collect all this critical data. And this is where OpenTelemetry, or OTel for short, comes in. It's a vendor-neutral standard for instrumenting your code. So what does that mean? It means you write the code to collect your metrics, logs, and traces just once using OTel. And then this little collector service can send that data to any analysis tool you want. Datadog, New Relic, Splunk, an open source tool, you name it. It completely separates the collecting data part from the analyzing data part. And that is what frees you from vendor lock-in.
So where is all this headed? I mean, collecting all the data is really just the beginning, isn't it? The real goal here is to build a much more intelligent and maybe even an automated future. Yeah, the journey definitely doesn't stop once you have your logs, metrics, and traces all set up. It's really about evolving how you use that data. And this observability maturity model, it's like a roadmap. It shows you the path from just knowing something is broken all the way to preventing it from ever breaking in the first place. The crucial point here is that each of these levels builds on the one before it. So you start with your basic monitoring. Then you add the 3 pillars to get full observability. The next step, causal observability, adds topology, which is really just a map of how all your services are connected, so you can understand the whole chain of events. And then finally, you get to the top, proactive AI ops. This is where you actually start to predict the future. And this is where it gets really exciting. We're talking about AI ops algorithms that can sift through literally terabytes of data to find these tiny, subtle anomalies, the leading indicators that a failure is about to happen. And this is what allows for automated fixes, moving teams from constantly fighting fires to actively preventing incidents before a single user is ever impacted. It's huge. Which, it leaves us with a really fascinating question for the future of engineering. As our systems get smarter and smarter, does the role of the engineer totally shift? Do we go from being firefighters, always putting out the next blaze, to being architects of resilience? Moving from fixing what's broken to designing systems so incredibly resilient they can actually fix themselves? It's something to think about. That's our explainer on observability. Thanks for joining us.